We'll be using the Phet DC Circuit Lab sim to investigate how resistors behave when added in series and parallel. We'll build a circuit using a battery. We can check the voltage here. The default is 9 volts, so we'll use that. We'll include an ammeter, and a switch. And we'll start with one resistor. We'll include another ammeter here to check the current flowing through the resistor. And then we'll connect this up with some wire. If we connect the switch, we see a current of 0.9 amps flows through the circuit. We can choose to see conventional current flowing out of the positive terminal, or look at electron flow that flows out of the negative terminal of the battery. We can also measure the voltage across the resistor, and we find that this is 9 volts. Using the definition of resistance as the ratio of the voltage applied across the device to the current flowing through it, we can see that the resistor has a resistance of 10 ohms. This is the default value if you place a resistor into the circuit in this Phet. We can now add a second resistor. If we close the switch, we see that the current flowing through the resistor is now 0.45 amps. And this is half of the previous value, meaning that resistance is now twice as large. We'll add a third resistor and another ammeter just to check the current flowing in between the resistors. Now if we close the switch, we can see we get 0.3 amps through the battery and through the resistors. This is a third of the original value, which means that the resistance of this group of resistors is now 3 times as large, so is now 30 ohms altogether, which is the sum of 3 lots of 10 ohms. We can check the voltage over each resistor individually, and we see that we now have 3 volts over each individual resistor. So what this means is that the resistance is that the voltage over each resistor is a third the value, so the electric field is a third the value. So that's why we get 1/3 the current. Note that the current is the same through each resistor, as this is a series circuit with no branches. We can also build a circuit to check the equivalent resistance of resistors in parallel. We begin by adding a second resistor and another ammeter so that we can check the current through each individual resistor as well as the current through the battery. When we switch the switch on, we see that we have a current of 1.8 amps flowing through the battery, and 0.9 amps flowing through each individual resistor. So this is because the current splits when it reaches the junction, and because the resistors are the same size, half of the current goes through each branch. We can see it doesn't matter where we put a terminal of our voltmeter on each side of the circuit, we've got the same potential difference all along each side of our parallel combination of resistors. So This means that the equivalent resistance of this group of resistors is 9 volts divided by 1.8 amps, which is 0.5 ohms. So we can add more resistors in parallel. And here we add another ammeter just to make sure we're checking the current through each individual resistor. So we can continue to add to our circuit like this. When we compare the voltage across the group of resistors to the current flowing through the battery.